Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
This episode is proudly sponsored by Metageek. For more than a decade, network professionals have used Metageek Wi-Fi tools to deploy, maintain, and troubleshoot wireless networks. Visit metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of Metageek brand hardware and software. Hi everybody, welcome to a brand new episode of the Clear to Send podcast. We have a great interview lined up for this episode, but before we get to that interview, I want to introduce Francois, who's back for the new year. You've been quite busy, Francois. How are you?
Yes, I'm very good. Thank you, Roel. Yeah, I'm really happy to be back on the show. I've been really busy lately. I wasn't able to make it to the previous episode, so I'm excited to be back for the new year with you hosting the podcast.
Yeah, and you're showing a lot of commitment here because you are in Abu Dhabi, which is about 12 hours ahead of me. It's really early in the morning for you, so really appreciate you taking the time out of your sleep.
Yeah, like you said, we have a very exciting interview today. I didn't want to miss it, so I just put my alarm clock and wake up the podcast, and then after that, I'm going right back to bed.
Awesome. Well, let's introduce our guest here. He is the Senior Director of Wireless Connectivity at Broadcom. His name is Vijay Nagarajan. Did I say that correctly, Vijay?
That sounds good.
Awesome. Why don't you introduce yourself?
Well, sure thing. Thanks everyone. I appreciate your inviting me over for this podcast. Very excited to share the benefits of 11AX and among other things. So my name is Vijay Nagarajan, and I'm the head of marketing for all of mobile connectivity at Broadcom. In other words, any of the, or mostly Wi-Fi, Bluetooth, or GPS that you see in your high-end premium class smartphones comes from my group. So we do high-end Wi-Fi, Bluetooth combo chips at Broadcom that go into high-end phones. There are other businesses at Broadcom that also focus on wireless infrastructure devices like routers, access points, set-top boxes, and so on. My focus specifically is on the phone side. So that's my role basically right now, where there's a lot of product management, a lot of business development type activities that are focused on Wi-Fi products and Wi-Fi standards.
Awesome. So how long have you been at Broadcom?
This would be my 10th year at Broadcom.
Nice.
So started off in 2008. And started off as a grassroots product manager and worked my way up this business group, and running the group right now.
Cool. And how did you get your start into wireless? Like, how did you get into that field?
Well, that's a good question. I guess there is a little bit of childhood passion, so to speak, which sort of morphed its way ultimately to land on wireless. So when I was a kid, I wanted to actually be an astronaut, go to space, and now that slowly morphed into, okay, I want to be an aeronautical engineer. And then I figured, okay, in aeronautics, a lot of aeronautics is really wireless. So I wanted to be in wireless communication. So I ended up doing my undergraduate and graduate degree in wireless communication and signal processing. And then, decided to pursue a career in wireless. Started off as an engineer, doing a lot of pen and paper work, algorithm design for CDMA and WCDMA phones. And at some point in time, the impact of doing just the engineering piece of it was not satiating for me. I did want to see the business side of things, to have a more holistic perspective. So I moved from being an engineer to being a product manager, and that's how I landed where I am today.
Cool. And I notice, correct me if I'm wrong, you were vice chair of the 802.11ac marketing task group.
That is correct.
Well, what is entailed in being in that position? What do you do for the Wi-Fi Alliance, and what was your experience coming out with helping bring up 802.11ac?
No, that's a great question. So this is, as part of my early days at Broadcom, I was tasked with representing Broadcom in the Wi-Fi Alliance on 802.11ac. And Wi-Fi Alliance, as you are well aware, is the certification body, so to speak, for Wi-Fi related standards and devices. The IEEE that specifically describes what the standard needs to be, and there's Wi-Fi Alliance that takes the standard and frames a test certification program around it, and ultimately certifies devices to be Wi-Fi compliant. And as part of the Wi-Fi Alliance, whenever any standard or any new program happens, there are two different task groups that the Wi-Fi Alliance has. One is a marketing task group, the other is the technical task group. The marketing task group is responsible for framing a statement of work, framing a marketing requirements document, and also putting a stake in the ground as to what the market timelines are, when does the program need to launch, what features should be covered as part of the launch, and so on. So, and as part of the leadership for that task group, it was incumbent on us to go frame all of these discussions at the industry level, ensure that the participants are moving the standard in the right direction and in the right timelines. Among other things, personally, I focused a lot on framing the use cases for 11ac. So if you have access to the Wi-Fi Alliance 11ac MRD, there is a use cases section that are pretty much framed, meaning how is 11ac useful for the consumer, what are the different things that they can do, what use cases should the standard support. So once use cases are framed, then those use cases become the basis for the set of requirements or set of features that 11ac needs to support. So that was my contribution, among other things, at the Wi-Fi Alliance Marketing Task Group.
So does this mean that you also work with the IEEE? You know how usually the IEEE works on a set of features, and then the industry decides which set of features get implemented in the chipsets and in the real world. And sometimes you have some use case coming from the industry in order to develop new features. And then I guess putting those features to the IEEE to add to the standard. Do you work with the IEEE as well to improve the standard?
I don't personally work with IEEE. However, there are representatives from my company that do. So and there are folks from Broadcom that participate in the framing of these standards in the IEEE, and a set of folks that also participate in Wi-Fi Alliance. So I was focused more on the marketing elements in the Wi-Fi Alliance for the 11ac program.
Okay. Going into 802.11ac and then transitioning to 802.11ax, what do you see as the biggest advantage of going to AX? Because I think a lot of people feel AC is still newish. It's still, you just finished the wave 2, and we're now waiting for clients to pick that up, right? Devices to be fully 802.11ac, because we still have, I still see 802.11g clients out there. And I just didn't feel 802.11ac had the it wasn't as much of a kick as like 802.11n. It was more like I guess throughput to me is what we were getting, and wider channel widths. But I guess my main question is, what do you think is the biggest advantage going to 802.11ax? Basically, the differences between AC.
Sure. As a marketing guy, the first thing that I think about whenever there is a question of roadmap, whether it is standards or product, is the use case, really, right? So way back in 2010, 2011, when we were contemplating the launch of 11ac, and to be clear, Broadcom launched 11ac under the 5G Wi-Fi brand back in early 2012. When we did that launch, I think the focus was substantially on video consumption. So around the turn of the last decade, there was substantially more video consumption that we were noticing. And it wasn't just to the PC as it traditionally was, in the early 2000s, but there were a wide variety of wireless devices on which video was getting streamed, mostly downlink traffic. TV, set-top boxes, phones, tablets, PCs, the number of devices on which you are watching your video grew. Right? So when you looked at data coming from Cisco on the VNI reports, or Wi-Fi wireless usage type analysis that came from several analyst firms, we could see a spike in usage primarily driven by video consumption. And obviously at that time, the problem or the challenge was only going to get acute in the later years, right, beyond 2012. Sure enough, we felt that the 11ac standard brought a couple of things that were very vital for video consumption. And I know I'm going to the details of 11ac a little bit, but bear with me because it's a progression from AC to AX.
Yeah, sure.
When AC was launched, I think obviously there was a throughput increase, right? There was a 3x throughput increase right away, where a single stream of Wi-Fi went from, say, 150 megabits per second all the way to 433 megabits per second, which is phenomenal. But in addition, I think 11ac also offered standard beamforming. So beamforming as a concept was standardized, which meant that there was much better link budgets being made available, much better coverage and capacity, because now you could focus transmissions between the transmitter and receiver, knowing the wireless channel quality and so on. So there was not just a throughput increase, but there was also definitely a sense that AC brought in better coverage and better capacity. And that certainly helped the video consumption story. And, as we've seen over the last 5-6 years, definitely the video consumption story has only picked up, with the Netflixes and the Amazon Primes of the world and all the OTT type devices working through wireless streaming. So that use case has definitely taken off, and therefore the bet on AC has definitely paid off. AC has sort of prepared the wireless world for the video consumption story. But now, as we look to the next 3, 4, 5 years, I think you will notice that there are more use cases that are getting added on in terms of consumer behavior. So it's not just video consumption. Now we're talking about video uploads, right? So you're talking about doing live social media streaming, right? You're at a stadium, you're seeing a football match, and you want to stream it to your friends live. You're at a music concert, you see Beyonce on stage, you want to capture it, you want to stream it. says upload, or you take photos, you want to upload it into the cloud. So what we've noticed on one side is, whether at a public venue or in the private confines of your home, there is a lot more upload traffic these days. And that we see is a trend that is set to grow on a go-forward basis. So consumer behavior is changing. There's social media live streaming, cloud uploads that require or necessitate a better story for wireless uploads. So that's on one side. On the other, the world's been talking about the Internet of Things and IoT and the number of devices in your connected home and so on. And as we've all been observing, I think that is slowly becoming a reality. Now, there are several reports that we can point to, but the notion that would be about 50 billion connected devices, say by 2021, 2022, I think is a consistent piece of data that we see in several media reports, right? Not just that, if you're looking at an average family of 4, Gartner says that will likely have about 50 connected devices. That's the second trend. So there's upload and there's a number of devices in your home. Now, the second piece where you talk about 50 connected devices, you may think, that is not true, right? That's not true. Because, why would a home have 50 connected devices or 50 Wi-Fi devices? Well, I go look at my home. I have, I believe, about 26, 27 Wi-Fi enabled devices in my home today. So at least from my vantage, it's not the 50 connected devices in 2022 is not beyond the realms of reality. So given these two trends, what we see is that Wi-Fi needs to drive, a change and go look at a redesign or a re-architecture from the bottoms up that would effectively make it more suitable for not just video consumption and downloads, as 11AC does, but also be more suited for upload and uplink traffic, and also this ever-growing notion or ever-growing number of connected devices in your home. So the twin trends of IoT and upload would be uniquely serviced by 11AX. So that's at least the motivation, and in terms of use cases, that is the change driver going from 11AC to 11AX.
Okay, all right. I can see those use cases because at my home I have a large amount of Wi-Fi capable devices as well, and as we see trending is those devices end up becoming introduced into the enterprise world. And I know in my environment I've already had people requesting to put Wi-Fi enabled light bulbs, Wi-Fi enabled locks. So there's going to be a lot of Wi-Fi devices. It's going to be more prevalent in our environment. So everything accessing the RF space. And then on top of that, I would say some people would say 2.4 is dead, but I disagree and say that now there are more and more 2.4 only devices, and a lot of those just being IoT devices. Because today I was just troubleshooting one device and it was 2.4 only. So then the next thing, I guess, is 802.11ax not only focuses on 5 gigahertz, and some of the basics there is that 802.11ac had a primary focus on 5 gigahertz, whereas AX is gonna drive some, I guess, efficiency towards 2.4 and 5, because we're not. I guess 802.11ax isn't focused on increasing throughput, right? It's I've always heard it's increasing the efficiency for the transmissions of frames over Wi-Fi. Would you be able to go into some of those, I guess, basics people should know about 802.11ax?
Sure thing. I guess you're right in terms of efficiency and capacity sort of being the cornerstones for 11ax. But the truth is that implicitly translates to a better speed to most of your clients. If you can service more devices at the same time, more satisfactorily, all these devices are going to get an elevated throughputs, so to speak. So while the raw throughputs may approximately be the same going from AC to AX, the efficiency enhancements in turn do help in terms of higher throughputs or speeds afforded to any individual device, and hence the network capacity as well. At a raw, so from the notion of raw speeds, while a single stream of 11AC supported 433 megabits per second, a single stream of 11AX supports 600 megabits per second. This comes from a set of efficiencies that have been baked into the physical layer, including the use of the more advanced 1024 QAM modulation scheme that allows for more data bits to be packed in a single symbol of communication data, and therefore we can afford a greater peak throughput. So raw speeds do improve some, but I think the mainstay of 11AX, which is effectively a bottoms-up redesign of Wi-Fi going from 11AC to 11AX, is orthogonal frequency division multiple access, or OFDMA.
Okay.
So this is really the mainstay. And the way I typically explain this to people is I use the highway analogy because it's very easy to look at the analogy between the highway and Wi-Fi access, so to speak. So traditional Wi-Fi, A, B, G, N, 11AC, deploy what we call the collision avoidance mechanisms in the MAC layer.
Hey, Vijay, sorry to interrupt you there, but I think your microphone is hitting your shirt.
Okay, I think I shouldn't be moving. Sorry about that.
No.
Is this any better now?
It is. I just want to be sure people get your OFDMA highway analogy. This episode is proudly sponsored by IPA, the visual packet analysis software from MetaGeek. As a Wi-Fi professional, you probably understand the benefit of packet analysis for troubleshooting wireless issues. And if you have any experience with most common packet analysis solutions out there, you also understand that sifting through hundreds of lines of data to find the cause of a network problem is a little like looking for a needle in a haystack. IPA takes a visual approach to wireless frame analysis. So instead of dumping raw packets for you to evaluate, IPA presents your data in multi-layered pie charts that make it easy to understand which networks, devices, and packets are using your available wireless airtime. With fast and easy filtering options, color-coded labels to show data throughput versus management overhead, and expert tips based on observed conditions, IPA makes 802.11 frame analysis easier than ever. Visit metageek.com/CTS and use the code CTS10 for 10% off your purchase of IPA.
Of course. So, yeah, I mean the analogy between the highway and Wi-Fi access is pretty straightforward and interesting. So, as I said, the prior generations of Wi-Fi going from A, B, G, N to AC deploy what is called the collision avoidance mechanism in the MAC layer. What it means is that at any point in time, only one device transmits, and the other devices are patiently listening to the air, listening to the medium, and waiting for their chance to transmit. This is, say, similar to having one car or one vehicle go through a road at any point in time, or in other words, having vehicles go one behind the other in a single lane highway. So what happens if you are on a Ferrari, but ahead of you is a very, very slow bike? The highway is only as fast as the vehicle ahead of the pack, really, right? Or rather, it's only as fast as the slowest vehicle on the highway, in this case, the bike. So it doesn't matter if you have a Ferrari, you're kind of stuck behind this very, very slow bike, and that has an effect on your ETA, when you can get to your spot, and so on. Quite similarly, when you take traditional Wi-Fi, you have devices that are at the hairy edge of the network, which means they have really bad air quality or signal quality. And so they will be using a very, very low data rate, which in turn would require them to use most of the medium in order for the data to get through. And there may be other devices that require much higher throughputs that are closer to the network and so on. Mm-hmm. So when this inequity happens, the network gets bogged down by some of these slower devices, as a result of which the network capacity is suppressed. So, and effectively, you're not servicing all the clients that you could have satisfactorily. Not just that, because all of these clients are patiently listening to the medium and waiting for their chance to transmit, they're effectively draining their batteries too in doing so. So the effect on mobile clients and IoT devices with this collision avoidance mechanism in traditional Wi-Fi is you end up draining your batteries a lot faster.
Okay.
11ax fundamentally solves the problem by introducing OFDMA. And OFDMA is akin to not just it is akin to slicing your highway into multiple lanes and allowing vehicles with different speeds to travel in different lanes of varying widths. So you can envision a situation where the highway gets divided into basically two: a narrow lane for the bike and the rest of the space for cars such as your Ferrari. So in this case, you are effectively servicing the needs of both the bike and the Ferrari at the same time and in a very optimal manner. So likewise, in a 11ax network, as I said, you are expected to have devices that want to transmit, that want to receive, and you also have these IoT devices that would require small amounts of data sporadically or in a continuous fashion. So what you would ideally want is a mechanism where you can actually splice the frequency spectrum into bands or bandwidths that are proportional to the needs of the different devices, and be able to service them simultaneously. So effectively with OFDMA, you're not just slicing or splicing these devices in time, but you're also allowing them to splice the frequency spectrum. So effectively, you are using the air medium in a much more efficient manner. Mm-hmm. You get to service these IoT devices, which require, say, a continuous or a bursty spurt of a small amount of data, while at the same time, you're servicing devices that require video downloads or meet your social media live streaming needs. So that's what OFDMA does. Now with that comes a lot of additional benefits also. So because OFDMA inherently involves a scheduled system, devices are effectively scheduled in terms of when they can transmit or receive. This is particularly useful also in terms of maintaining the battery life for your clients, your, say, mobile clients or your IoT devices. So to that end, 11ax introduces this notion of target wake time, or TWT. And TWT effectively is a mechanism that allows the mobile devices or the clients to go to sleep and wake up only when it is their turn to transmit. So effectively, in 11AX with TWT and with scheduling, the router is pre-negotiating times with your phone and your IoT devices as to when it is their turn to transmit. So what would happen effectively is they can safely go to deep sleep in all other instances, at all other times, just wake up when it's their turn to transmit. So effectively, you're saving your battery life. So
it almost sounds like instead of devices contending for the medium, it sounds like the AP is going to hand out tokens and say, all right, this is your time to transmit or receive, and then move on to the next device, and all right, this is your time to transmit and receive. Is that fair to say, or is that
is
different?
That is absolutely fair to say. So,
okay.
Yes. So I'm trying to sort of break it down into a very simple narrative, but yes, that is absolutely right. So there is a scheduled access which is being controlled by the access point that manages when devices get to transmit or receive. And again, the analogy that I would use here, which we've actually put out as a video online as well, is let's suppose there are 4 people in the house, and they all have to wake up at different times. In a 11AC type scenario, they'd all be sleeping in the same room, and this alarm would ring every time somebody needs to wake up. And effectively what happens is all the guys when everybody else is waking up at that same time, and then they realize, okay, this is not my turn to get up and I'm going back to sleep. So however, with TWT, now you can imagine a situation where you have dedicated alarm clocks for each of these individuals that only wake them up while all the others are sleeping. So effectively you're waking up with a lot more energy to go through with your day. Now, quite similarly, your devices are left with a lot more energy or battery life to go through their lifetime. So that's the analogy that I use to explain TWT.
Okay, I think that's a plus side for everyone who's got their mobile devices. But I guess my second question to that is, if you have an AP that's using OFDMA, it's 802.11ax. You got devices that are AX. What about backwards compatibility for devices that are not using AX? Are they still able to use some of that function of 802.11ax with the TBT or
TWT?
Or TWT? What happens there?
So the answer is no. So the backward compatibility exists, by the way. I mean, that's not the problem. But these advanced features are applicable only to 11AX network. So what happens is effectively this scheduled access at TWT is built on top of a collision avoidance mechanism so that you can make sure that your existing ABGN AC devices are also operational in a mixed mode network. So essentially, we are backward compatible, while at the same time ensuring that the AX devices in your network are able to effectively use the medium through OFDMA.
Okay.
So OFDMA is basically, we have our channel, 20 megahertz wide channel or 40 or whatever we're using, and then we're subdividing the subcarrier, and then we're allocating a certain subcarrier to a certain client and so on, so we can send traffic to multiple clients at the same time. We've had the OFDM, so we've had the subcarriers for quite a while now. If we go back AC and G and A. So my question when I first heard about OFDMA is, why didn't we use OFDMA before?
Well, there's got to be a time for everything, I suppose. So, I mean, the Wi-Fi, and I'll give you my answer. You may hear different opinions from others, but effectively, Wi-Fi was built as at the get-go, was built as a relatively simpler wireless standard that was based on collision avoidance. It was envisioned for home type scenarios with not much mobility. And, there was enough juice in the, in the other physical air enhancements and the availability of spectrum that we could go progress on, several of the KPIs for Wi-Fi, going from one generation to another without, completely re-architecting the MAC, so to speak. So this way, the industry was able to hang their hats on collision avoidance. However, use higher modulation schemes, use better error correction codes, use things like beamforming, wider channels, use of 2.4 and 5. There are several of these knobs that progressed from one generation to another that, again, going back to address the use cases of that time, right? So now as things change and as user behavior changes to more and more complex applications and use cases, there's certainly a need to step back and look at what is a more efficient mechanism to use the medium. To be clear, the previous generations of Wi-Fi also use OFDM, right, or open frequency division multiplexing, as you alluded to. Effectively, there are subcarriers, and converting that or using that physical layer framework to introduce a multiple access scheme is sort of the innovation that 11AX brings to the table. So instead of allotting all subcarriers to one user in a single user type scenario, now you get to allocate it partially to different users, multiple users.
You mentioned about the availability of the spectrum and OFDMA and how there's the efficiency within that channel, the frequency there, how it creates multiple lanes. Are we going to see any kind of efficiencies or improvements when people start using bonded channels and then have overlapping BSSs? Are we still going to see that co-channel interference, or is there any way in 802.11ax that it with the APs knowing about each other and what channels they're using, is there going to be any advantages using OFDMA with overlapping?
That's a good question. There is. And AX also introduces this concept of coloring, spatial channel reuse, and effectively coloring of channels. So there is for adjacent BSSs, there is a signature that is associated with each of these BSSs, and this coloring helps these networks use the available frequency spectrum more efficiently, and spatial reuse is the reuse of spectrum by way of the spatial reuse mechanism is definitely a lot more efficient in terms of, or a lot more effective for the scenario that you brought up. So this concept of spatial reuse is absolutely something that aligns with what you just brought up.
Okay, so the devices would be associated to a BSS, and they're, say, color blue. The adjacent AP is color yellow. So if devices in blue start seeing frames that are yellow, it's just going to ignore it?
That is correct.
Okay.
That is correct. So
but then my mind
spatial reuse.
But then my mind can't wrap around transmissions occurring at the same time of a device in blue and a device in yellow. Wouldn't that interfere with each other? That's the part I still don't quite understand.
Yes, they would, but I guess that is where you start looking at relative signal strengths and then make that determination, right? I mean, you are going to have some exceptions, and there is, enough. Enough mechanisms built in to this coloring scheme that would address concerns that you bring up. And there's no doubt that there's going to be these corner cases as you're trying to more efficiently use spectrum.
Yeah, because I think it's interesting with the coloring, you've essentially put on some earmuffs on devices, so that way they don't spend time processing traffic frames. Yeah. That's not part of their BSS. They don't waste that airtime. But I'd like to see it.
You probably need a high SNR.
Yeah, I'd like to see it in action. But because it's hard for me to really grasp the concept, but I kind of understand where it's going, and I think it's interesting. It'd be really
look
interesting
at it
to see
this way,
once
right? So it is going to be better than if you had no color, right? What is your fallback? The fallback is you act as if there's no color, really, right?
Okay.
So effectively, the scenario is going to be that it is going to be better than when you had no color at all.
For some reason.
So what about multi-user MIMO? Can you talk a little bit more about?
Oh, that's a good one, Francois.
About that, and what new feature AX will bring to multi-user MIMO?
Sure thing. So multi-user MIMO is very much, a part of 11EX as well. So at the outset, as you introduced, AC and AX, you talked about AC Wave 2. Yes, AC Wave 2 introduced multi-user MIMO, but in my experience, I've not necessarily seen a wide adoption of multi-user MIMO in mobile client devices. Doesn't speak to it not being a valuable technology, but in the time frames that we've talked about, multi-user MIMO has not gone into the mobile phones. However, as AX rolls in, OFDMA definitely becomes the marquee feature, but in scenarios where you have a limited number of users requiring a relatively high throughputs, then multi-user MIMO could help. Right. So when you have 2 or 3 users that require relatively high throughputs, then you can envision the scenario. You can envision putting them in a multi-user type configuration to NU MIMO. However, when you're looking for a more generic use case or scenario where you have more number of users, you have IoT devices with varying requirements, or you're in a venue where you have multiple devices requiring different amounts of throughputs, downloads, uploads, and so on, then OFDMA offers that much more flexibility. So they're both useful, they're somewhat complementary, and you could, in my opinion, envision sort of orthogonalizing the use cases for these two.
So I have 2 questions for you now. The first one is OFDMA compatible with multi-user MIMO? Can they both work at the same time? I have a difficulty understanding how they will both work at the same time. And my second question is, are we going to have multiple wave for AX, kind of like what we did with AC, and then each wave introducing a new feature? Can you talk a little bit about that and how Broadcom is thinking of doing things?
Fair enough. Let me sort of focus on the second one first. So, as you alluded to earlier in the call as well, IEEE ratifies a standard with a set of features, and the Wi-Fi Alliance is a certification body, and as a set of companies coming together for the certification, determine that a subset of features are what is required for that time frame, right? That's exactly what happened with 11AC. There were features that were picked as being mandatory and optional for the first wave that got released, and then multi-user MIMO made it to the second wave of products, so to speak. With AX, obviously, at this point, we've determined between, at the Wi-Fi Alliance, there are a set of features that have been determined as, again, mandatory and optional at this point. So the industry is, single-mindedly focused on getting these features into a meaningful test plan and certification process at this point. I believe if there is a need to incorporate more features at a later date under the AX umbrella, that's something that the industry would consider. But I would personally post that as an open question at this point.
Well, what does the time frame look like? Sorry, Francois, go ahead.
Sorry?
No, I was going to ask which features are you working on right now?
Again, primarily, there's a lot of focus right now on, OFDMA, right? So it's primarily OFDMA, uplink, downlink. We, at least at Broadcom, we're very committed to, making OFDMA happen and effectively both downlink and uplink OFDMA, because for us, we see that as, like I said, the biggest change going from AC to AX. This for us effectively introduces a better multi-user scenario. Can they work together? Again, I think I mentioned in my earlier answer that you could sort of orthogonalize the use cases, right? So I think I would look at it as one or the other, depending on the use cases. And again, if you're in your home and like you and two other friends, and each of you effectively want a very, very high bandwidth, so the capacity maximization plan could be multi-user MIMO, where each of you sort of orthogonalizes your data stream and then sends it out. But again, if you're talking about a connected home with a varied number of devices with varying requirements, then or you're in a venue, I would focus a lot more on OFDMA.
Okay. So
I guess that would be interesting to see. Is the AP going to detect which one to use or how to deal with the clients? That'd be interesting to see.
It would be, but my bet is, again, this is my personal view. I think the focus or the priority will be a lot more on OFDMA, just given the flexibility that it has to offer.
Yeah, I say forget all those old devices. On with the new.
Sorry?
I say forget all the old devices. On with the new devices.
No, of course not. Obviously we can't do that. Jokes apart. And one of the basic premises for Wi-Fi is, or the reason why Wi-Fi has proliferated as a brand, and people have used Wi-Fi, is the very fact that all these devices are backward compatible one generation to another. So again, definitely. Whether it is the industry standardization body, the chip vendors or OEMs, there's a very conscious effort to make sure that there is backward compatibility going from one generation to another. And as I said, going from AC to AX, the OFDMA mechanism is effectively built on top of collision avoidance, right? So if you have a legacy device, you still contend for the medium, and the AP contends for the medium with these other legacy devices. And when there are no legacy devices transmitting, then you do an AX transmission.
Okay.
Right. So there is absolutely need for backward compatibility, and there will certainly be focus on it.
I guess to wrap things up here, can you talk to us about timelines that Broadcom has? Do you guys have a chip already, and why come out with a chip soon if 802.11ax hasn't been ratified yet? Can you talk about where Broadcom's going?
Thanks for the question. So we're back in, it's late summer this year. We announced our set of chips. We announced 3 chips under the Max Wi-Fi brand. If you've noticed the logo and the brand itself, it's our take on 11ax. We did launch a set of chips. One was a phone chip, chip that will be used for premium phones, called the 4375. And we did announce a couple of chips for the infrastructure side as well. The 43684 that would be used for retail routers, and 43694 for enterprise access points. So we announced a complete suite of 11ax devices, or Max Wi-Fi devices, so to speak, late last year or mid last year. Our plans effectively, as I said, we do have chips, and we're already working with our customers to go enable it. If you go back to the press release that we made back then, you will notice several of our customers indicating that they're actively working with us already to bring end devices to the market. Subsequent to that, a couple of the router OEMs did make 11AX announcements that they would have routers this year. And so you should start seeing, retail routers in the market in the next several months. There are other infrastructure segments also that are pretty hot on 11AX, on the enterprise access point side. Carriers, carrier gateways, they're all super excited about picking up 11AX. So we do see a relatively good starting point in terms of 11AX deployment or Max Wi-Fi deployments this year, and growing next year as well. And then from a client standpoint, we anticipate the first set of clients to start, 11AX clients to start appearing in the market next year. So, effectively, through 19 and entering 20, you should see a very healthy ecosystem of 11AX or Max Wi-Fi devices, in my view. Again, this doesn't, that's just our forecast. It's not specifically tied to any one OEM. It's just our forecast of how we see end products lining up in the market.
Mm-hmm. Awesome. Yeah. I like where it's going.
Sorry?
I like where it's going because you guys are trying to be, ahead of the game, and you're really trying to push for the newer technology, trying to be in the market first. So I like to see how this plays out and see what devices come out and start testing some of this, because I'm definitely looking forward to it.
Absolutely. We're super excited. To sort of answer your other question, if you look at how we've done our technology launches, we've always come out and launched, we've sort of led the market in terms of generational launch of Wi-Fi, whether it was 11N, G, N, AC, we've always been first to market in terms of launching devices. And with AX too, that's very true. 11AC, we launched our chips in, at CES of 2012. This was ahead of when the Wi-Fi Alliance was going to certify AX. However, there was a commitment from us that any changes, if at all, would be typically upgradable by software. So we've never had an issue there. With AX2, that is how we see things evolve. That is certainly a market need that we believe in, both in terms of use case and in terms of our customers, especially on the infrastructure side, being excited by the generational change in Wi-Fi. And that in turn sort of necessitates us to go deliver these chips first to market and well ahead of everyone else.
Cool. Well, I want to thank you for joining us on the show, because this is the first time we've had a discussion about 802.11ax, and I think it was a great starting point to bring the topic to the listeners, and hopefully we can have more discussions around AX as we get closer to the equipment and devices, that basically the APs and devices to come out, so that way we can start testing them and have even more discussions around it. Why don't you let everyone know where they can reach you, if you're online, social media, or a website?
I'm available on, I'm personally available on LinkedIn, so you should be able to get in touch with me there. Of course, we do have if you want more details on 11AX and the Broadcom flavor of it, we have a website, which is maxwifi.org. Please feel free to look through that, and you should be able to get a lot of details on what 11AX is about. There's a lot of material there. My LinkedIn site also carries a lot of material on 11AX. Viewers, please feel free to reach out to me if you have any questions.
Cool. Well, appreciate you joining us on the show. There's a lot of great information to see where you are and where your stance is with Broadcom, where they're coming from, and how you guys are able to help improve the Wi-Fi industry. So thanks again for joining us on the show. And thank you guys to the listeners for being part of the podcast and giving us input on what you guys want to hear. And if you guys have any questions, go ahead and feel free to reach out to us on Twitter at ClearToSend. You can also hit the Ask a Question button on the website. We'll have the show notes up along with a press release and some of the chips that have already been released by Broadcom on the show notes. Head over to cleartosend.net for that information. So I just want to thank everyone again. Thank you, Vijay, for joining us. And we hope you guys have a great day, and we'll see you on the next episode.
Absolutely. And thanks both of you. This was a wonderful interview and appreciate the time here.
Thank you.
Thank you, Vijay.
Thank you.